Alright, so I got some worried emails, some concerns about this quiz. So I'm going to review a few things with you guys that's on the quiz. Okay, we have to think about what is a function. Right, a function is when every input has only one output. Okay, we check this in a few different ways. For our graphs, go down here. Erase this real quick. Okay, so for our graphs, we do a vertical line test. You can draw vertical lines all the way through this first graph, and it never hits 2 or more. So that is a function. We look at the second graph, we draw a line. Okay, so this tells us that our x value has 2 different y values, which means it has 2 outputs. So this is not a function. Not a function. Okay. Now we're going to review whether or not these are linear functions. Are they linear or non-linear? Okay, when you're looking at graphs, it's easy to tell if it's a line, it's linear. So we're going to say this first graph is, of course, linear. The second one, it's 2 lines connected. That's not just one line, that is non-linear. Okay, now we're going to look at what their domain and range is. So when I say domain, you should always think our x values / input values. So when we're looking at our x values, for this first graph, we're going to say what's the smallest x value on this x-axis that our line lines up with. I'm going to say it's this one right here at -8. I'm going to go all the way over to the farthest right point that we have on our line, and this is +9. So our domain, D for domain, is -8 less than or equal to x less than or equal to 9. Okay, now let's talk about our range. Our range is our y values, or our output. So on this graph, we have to look at our y-axis, which is this vertical axis. What's the maximum, the highest y value? I'm going to say right here at 6. And the lowest y value it is reached right here at -4. So our range, I'm going to put r here, is our smallest number, -4, less than or equal to y, less than or equal to 6. Okay, now if we're going to do this for our graph on the right, I'm going to write our domain. I look at our x-axis. What is this? This is -8, and the farthest right is right here at 9 again. So our our domain is -8 is less than or equal to x, which is less than or equal to 9. Now we have our range, which is our y values, our y-axis. Our highest point here is an 8, and it goes all the way to our lowest point here, which is -7. So we have our smaller on the left, we have y in the middle, and then we have 8. Okay, so to remind you, function, vertical line test, linear or nonlinear, whether it's a line or not, Domain is our x-axis, our x values. Range is our checking our y-axis, our y values. Now, real quick, let's talk about ordered pairs. So, we have to say if this is a function or not. Remember what we said, every input has to have exactly one output. So if we look at this first section, we have 2, 3, 1, and 9. Each of those are an input and they each have an output, so that is a function. Let's look down at 2. We're checking all these inputs, 8, 3, 9, and -2 again. 8, 3, 9, -2, they all have exactly one input. This is also a function. Now, because they have specific points, we can say our range would be our y values, which is -3, 4, and 2. On the bottom, it's -3, 8, 4, and 2 again. So for domain, we're just listing our x values again. We have 2, 3, 1, 9 on the top, 8, 3, 9, and -2 on the top as well. All right, let's check out this table. Okay, is this a function? We have to check our inputs. Do our inputs have more than one output? Okay, I have a -2, a 0, and we have a second -2. So our input -2 actually has two outputs, 6 and 20. Okay, this is a no-go. This is not a function. No, we can't have it. So because it's not a function, we have to move on to the other. It's not a function. We're not going to say it's linear. We're not going to say it's nonlinear. So then we have our other table here. I'm going to clean this up. So we're going to figure out first, is it a function? Well, we have -3, 0, 3, 8, and -10. All of those are inputs that have exactly one output, so this is a function. Now, how is it linear or nonlinear? Okay, we have to look for a constant rate of change. So every time the change in x should be the same and the change of y should be the same. So for the x values, we always add 3. We add 3. Okay, now from 3 to 8, how many do we add? We actually add 5. And from 8 to -10, we actually subtract, how many is that? -18. Okay, so we can already tell that this is not a linear function because this rate of change is different. So this is not a linear function. Now we're going to check down here. Is this a function? Absolutely. Every input has only one output. We look to our right. Is this a function? Absolutely not. You can see 15 has both 7 and 9. This is not a function. Okay, let's check what else we have to look at. Okay. So looking at these two graphs, you should be able to tell me right away that the first one is linear, and the second one is nonlinear. You could just tell, look at it, it's not a line, it's nonlinear. Something else to note is that it gives us the equation, And it says x cubed minus 6. So this is a good representation of how any exponent is going to make it nonlinear. So let's check these tables. We'll do one table and then we'll go through our equations real quick. So this rate of change for x for our first table is 1 each time. For the bottom, it's plus 3 each time. Because that rate of change is the same for the x and then all the y's are the same, this is in fact linear. If we look to the one on the right, it's going up by 1 on the x side, and it's going down by 1, up by 1, and then up by 3. So this is not linear. It's not a constant rate of change. All right, looking at y equals plus x to the 5th over 3. Well, there's that exponent, tells us right away, nonlinear. We're looking at the second problem. This is in the form y equals mx plus b, so this is in fact linear. This last one, we have the exponent again. It is nonlinear. Some other things to look for is when x is below the fraction bar. It's automatically a no-go, nonlinear. If it is on top of a fraction bar, like on top of 4, this is linear because we can rewrite that as 1/4 x. Let's do problem of the day. We're evaluating functions. We're going to save that for another day. We're going to go all the way down here. We're going to check out this graph. This is also on your quiz. You're going to always plug in the points -2, -1, 0, 1, and 2. This should not be difficult. 2 times -2 gives us -4, plus 2 gives us -2. -1, plug that in, we get -2 plus 2, that's 0. Plug in 0, we get +2. We plug in 1, we get 2 plus 2, which is 4. Plug in 10, we get 4 plus 2, which is 6. Once you have those values, it should be easy sailing from here. All you got to do is plot your points. So we have, we'll say this is -2. -2 at -2. So I'll plot my point right here. Then we have a -1, go -1, 0. My point is right there. At 0, we are at 2. And then over here at 1, we are at 4. We'll say that as 4. And then over here at 2, we are at 6, so that is up here, and then we draw our line. And that is all you have to do for graphs. So when you get to the quiz, all you have to do is make a table and then check to make sure that the graph is the correct one. All right, so what do we have left? We have one more thing I want to talk about, and it is discrete and continuous. So let me find this real quick. That one. Okay, so here's the thing. A discrete domain. Let's go up here. A discrete domain is always going to be particular or specific numbers. So it'll be numbers that we think about and find, or it'll just be given to us, like 1, 2, 5, 6. Any numbers. It could be a negative number. This would make it a discrete domain. Continuous domain would be when you have an interval. So if you look at this line, it shows us that everything from 1 to 5, whether it's 1. All right, and we're going to keep going. Sorry for the cutoff there. I ran out of time. So we were talking about discrete and continuous domain. Our continuous domain is on an interval, which is what we looked down that little line graph. So let's talk about it in the context of a word problem. So our example, the linear function y equals 15.95x represents the cost in dollars y and x tickets for a museum. Each customer must buy a maximum of 4 tickets. Find the domain of the function. Is it discrete or continuous? And explain. So we're just going to work on that A. That's what we're talking about. So first I want to talk about what's the independent variable here. It's x. Okay, this is also known as our domain. And our dependent is y. Okay, y depends on what we plug in for x. Okay, so our question is, what is x? Okay, they don't give us specific numbers. They don't tell us explicitly what we're going to plug in. We just have to read between the lines. So it tells us x tickets for a museum. So tickets is what we're talking about. And each customer can buy a maximum of 4 tickets. So that means they can buy 1, 2, 3, or 4 tickets. Okay, so tickets make our domain discrete. That is because you can't split a ticket in half. You can't have 1 to 2 tickets because that's impossible. You can't have 1.9 tickets. You can't have 1.5 tickets. You can either buy 1, buy 2, buy 3, or buy 4. So that's what I mean by specific numbers. Let's look at the bottom example. We have a cereal bar containing 130 calories. The number of calories C consumed is a function of the number B bars eaten. So if it's a function of B, then bars eaten is our domain. And if you can write the equation for this, that's fantastic. We have C calories is 130 calories per candy bar, well, cereal bar. So our domain is our bars eaten. So they ask, is this discrete or is this continuous? So every time you figure out what the domain is, whether it's tickets, bars eaten, hours, whichever, you have to think, can I write this as an interval? Tickets, we said no. For bars eaten, we're going to say yes, this is continuous. Because you can eat half a bar, a bite of a bar, a third of a bar. You can eat 5 bars and half of another. So this is going to be continuous. Okay. What else does it ask us for? It does in fact represent a linear function. We know that. All we have to do is add 0, and it is in our y equals mx plus b form. Talked about that. And we just talked about how to graph, so yep, that's how a discrete and continuous domain works. And I hope this helps for your quiz.